因为帮我看一下那个 YouTube 那个 stream 有没有声音，还是听到吗
OK OK。
Hi everyone, welcome to Rust Malaysia, Rust Meetup. I believe who is first timers here? Everyone, welcome to. And how many of you are software engineers? Oh, you're software engineer? Student.
Hello, Ivan. Can you hear me, Ivan?
Yeah.
Hey, Ivan. The YouTube one, the screen is black out.
YouTube screen is black out.
Yeah.
Oh, okay. Oh, you're software engineer. YouTube. And now?
Wait. Still. Okay. Yeah. Now got ready.
Where are we? Okay. Now can see?
Wait.
Now?
Yeah.
Okay. So we are a group here, local group that is we focus on the language Rust. It's a programming language that is not quite new, but the community is a bit smaller. But it's a programming language that focuses on a couple of things. For example, it focuses on the productivity, the safety of the safety around writing the language. When you're writing it, the code is like very safe. And then the other thing is like it wants to be correct. It focuses on the correctness on the software. So our group mainly will be hanging around the Telegram channel. The Rust Lang Malaysia, we have a Facebook group as well. But we have a main Telegram channel where we share all our information. There's this slide I'll host it online later. So there's this main Telegram channel where we post everything, all the event updates, and yeah, and we also have a Discord where because like I'm Tham, and then the co-host is Jeffrey Lai. No, not Jeffrey Lai. Yeah, Jeffrey.
Jeffrey Lin.
Sorry. Yeah, so Jeffrey is another co-host. Jeffrey Lai was a previous co-host, and Jeffrey is not around here locally now in Penang, so he'll be joining online this time. And we'll be hosting the event online as well this time because there are a few people requested for it to be online. So they cannot join. And the news, for our group, we are bi-monthly Rust Meetup group. So every 2 months, the second Wednesday, we will host the event here. So most of the people a lot of them are new to Rust. Some of them are like a couple of regulars. Then we'll be hosting the next workshop. We'll be hosting it online for the Meeters group. We'll be collaborating with them, and it will be a online Chinese workshop. So mainly we will be using Chinese for communication, and it will be similar to the workshop we have done in June. But that one, because we have received some feedbacks where we will be, because that one most of the time we spend the time talking. Yeah, most of the time, right? The time we will spend like teaching the stuff. But this time the workshop will be focusing on the next workshop in December it will be Chinese focused, and then we will be changing the style a bit. So we'll move it more towards like solving puzzle kind of exercise, like doing exercism, doing more towards coding out stuff rather than more towards self-learning. People can do stuff themselves. And then some news. This here we will have like an update. So every time we will have a bus corner where we have new updates on what is new. So Rust 1.72 is released. There's some changes there, including like for example, the compiler report disabled, the CFG disabled. So CFG is a conditional compilation for Rust, and then last time, right, previously when the conditional compilation disable that chunk of code, the compiler won't go through those code. But now, right, in the error reporting, you will go through that code and then you will show like those code as well. There's some errors. Next thing is the Clippy lint being put into Rusty. So some Clippy is the like linter for Rust, but it's built into the language itself, the compiler. So it comes with cargo. These are built into the ecosystem. I mean, the one thing I quite like about Clippy is that it will lint not just the normal lint issue, it will also lint performance issues, which I like rare across other linters. But it's quite. But another thing I like is like there's almost no false positive. A lot of language I see, a lot of other linters I see, there's a lot of false positive. Then every time you go and disable disable here, disable that. But the Clippy, they don't enable lints that have false positive. And Rust 1.73 is like the latest one. So this one, there's now we have better panic message. Previously, both the error, the panic message here, you see, for example, thread main panic at oh no, the risk.txt not found. And then with the file line, the file where you panic at is at the same line. So now they move it separate line. If in case you all don't know what panic is like when the system goes into a very a place where it cannot recover the error. I'll talk about that later because today's topic will be about error handling. So once it cannot recover, then it will panic. So you just want to care about like how to handle it. Next is thread local initialization. Now it's way more ergonomic. Back then you need to do with where it wraps everything with and then you need to take a closure and then do stuff with the closure. Now we have a easier method and make it more ergonomic to deal with. Next is Rust in Flutter. So this is they built something like Rust using Rust as a Flutter backend and then Flutter as the Rust frontend. And then this one they built I think this one is for building Flutter apps, but mainly using Rust as the backend. But I wish there's something like Rust but for something like Flutter but in Rust. But so far I don't see anything. I think probably because a lot of work needs to be done on building these UI tools. And that is Rust Roll, JetBrains IDE kind of plugin. The Daywick JetBrains Rust plugin. This one I'm not sure. So these are like IDE. And then Diesel async. Diesel is one of the Rust ORM that's quite popular. It's quite interesting as in compared to other ORM, right? It's more like table based. So it's like a type safe ORM, as in when it compiles, it works. And then the interesting thing is that it do the type against the different database you have. So the type, right? There's a lot of like type magic around it. As in like you can run certain thing on certain query can be run on you can run on MySQL. Some you cannot run on Postgres, right? It handles those kind of cases also. Like I think returning or something you can run on Postgres, but you cannot run on certain SQL databases. Diesel even can handle those cases where, like for example, returning only works on this certain language. So when you use the Diesel, you run against that certain backend, then you make sure that the code is really targeting the backend. So let's say you run something that it doesn't support, so it will error at compile time. The interesting thing is Diesel async is like a project by Diesel where they bridge async and Diesel together because Diesel is mainly synchronous and the async allows using Diesel as a asynchronous connection. Now this Diesel can bridge between async connection and the sync connection, and this can now be used for migration, which is quite useful as in because last time you need to think because the migration is sync only, right? But you want to use the async connection. How do you do that? Do you need to create two connections? But now you can use the new async and use the bridge and run it for the sync connection. Next is the bare metal Rust in Android 14. So Android 14 we return their virtualization framework vector VM firmware in Rust. So it's like some low level stuff and then to avoid memory safety vulnerabilities in the future. But this is, I think, second, a couple of parts already there. From what I remember, last time they returned the Bluetooth stack. Previously, Android returned their Bluetooth stack first. So this is something new. Mainly, they want to write this to avoid the memory safety vulnerability. And next is the PayWax devlog. PayWax is a framework, the web framework that is quite new, and PayWax is done by the Luca Alcamari. If you don't know about the guy, I quite like his. He have a book, right, called From Zero to Production. I quite like the book because he shared everything, all the experiences he have. He built the website from scratch, and then of course he used web frameworks, build the website from scratch, and then he show all the pitfalls of like using, for example, using this authentication mechanism. He show how to do it the wrong way, and then he show how to do it the right way, and then why certain decisions was made. Yeah, you can have the pizza. So he showed certain, like, why certain decisions was made. That's why the book is, I quite recommend it for beginners. That is like learning any kind of web because that one is quite general, as in he showed all the different approaches he take to do the web, even cookies, how he handle cookies, and sessions, how he handle that. And now, because the guy, right, also wrote the PayWax, which is a bit experimental, the framework, I would say, but it's a bit, Rust already have a lot of frameworks, as like, for example, Exum, which is quite new, not that popular yet, but quite new, and it's backed by the Tokyo team. Then previously there was also Ethics Web. But PayWax is quite interesting, as in, because there's already so many web frameworks. So PayWax is trying to do something different, as in they want to take the error messages to the next level. As in, because Rust is known for the good error messages, but then for a lot of web frameworks, right, it's not like fully compile time type safe. As in, from what I see in the other web frameworks, like for example, Rocket, Ethics Web, Tokyo Ethics Web, and these two, and Exum as well. One issue they have is that the state, right? For example, you want to put in the state. When you extract the wrong state, it will have a compile time. No, it will have runtime error instead of compile time error. So they cannot catch this in compile time. I think Exum have a solution for that already, but Ethics Web and Rocket doesn't have a full-blown solution that, let's say, in compile time, it can figure out all these issues. So what PayWax did is they have some kind of compile time reflection kind of stuff where they can generate the dependencies during compile time. And then so they know like the dependency tree during the compile time, and then they know like, for example, this next, right, the middleware. So now they have middleware already with this new release, and then from here they know what kind of states are there. So they track all those dependencies using the compile time, all those at compile time. That's where I think it's. So they solve all this during compile time. And they also, one thing they like, their targets is better error messages. Nucleo is built by the Helix team. I'm not helping them to be, although I used to be in the Helix team, but then I like kind of quit already. But then, so Helix is a text editor for us, and it's based on, Helix is based on both Vim and Kakon, and then take a bit here and there. The text editor is also written in Rust. One thing interesting about it is it has most of the stuff built in. As in, like, for example, the LSP support, usually text editor don't have that built in, but Helix have it built in. The DAP protocol for the debugging, it also have it built in. LSP is for the language server. So once these two is built in, you don't really need to go and find add-ons to plug in the language server. Helix have all this built in, and the keys are more like a bit more similar towards the Kakun end. And Nucleo is the fuzzy matching library that they built from Helix team. Have anyone here heard about FZF? FZF, no. FZF is written in Go. Actually, yeah. So FZF, right, is like a multi-finder. You search. Okay, what I mean by that is like, for example, so the multi-finder means like this, something like this. So you search all, you list all through all the files like this, and then read me and something like this. So this is the multi-finder. So nucleo is just how you see the thing they're searching there. So it's on par with FZF, and it's 6 times as fast as Scheme. Scheme is a FZF phone written in Rust, but it doesn't use the same logic, search logic as FZF. Then D1, which is the fast, simple benchmarking tool written for us. There's a bench already, but I think this one just make it nicer. I didn't really check into the details, but this looks like just make it nicer. Just and then it also has statistics. The previous one doesn't have statistics. The one built in. So that's an interesting thing about even. And then the slides are here in case anyone wants to see the slides. Anyone wants slides? I'll publish it in the website because all our stuff is written here. We have all our slides in our website. Yeah, the previous videos, all recordings, yeah, all the slides all are here. Yeah, so our group, we have been running the meetup since 2018, and all the slides are there also. Okay, anyone have any questions regarding the?
Okay. It is on how yeah. It replaced. Yeah,
It's not logged in yet. They have some stuff is not.
I installed Helix allows me to install FCF.
Oh, I think maybe they haven't released a new version. Okay, now let's get on to the topic today. So today I'll be giving two talks. One is error handling, which is more beginner friendly one, and the other one is how to perform faster in Rust, which is a bit more advanced. So summary, error handling in Rust is a bit explicit compared to other languages because you need to type all the errors out, and then what kind of errors you will categorize it clearly, and all the types you know it ahead of time. And it works well with the rest of the Rust types. For example, the structures and enums. Enum is like some type I'll show later. And then there's also some syntactic sugar to make it easier, like error propagation. It uses syntactic sugar. So explicit in Python there's this something called import this, right? It will say a code that saying explicit better than implicit. So Rust errors are explicit. I'll show why, explain why later. So for example, you see Python, right? And you see Python the dictionary, there's this function called get item. When you look this I took it from the help page. When I see this, right, do you know what exception it raised? Like what kind of exception it raised? Yeah, correct, key error. But then a lot of time when you don't have the experience, you don't know like what kind of exceptions you will throw. Many times in the code base you need to go. I don't know whether you have covered this or not. You need to go dig into the upper function, to the inner function, and then see, oh, does this raise error? Oh, this doesn't. But then inner function, or maybe it does. So you need to dig another level, dig 3 levels. Then, oh, this throws an error. I need to handle it here. And this is why I say the errors are explicit in Rust compared to quite a few other languages. I mean, more explicit, not really, because there are some errors in Rust that are a bit implicit, but still, as in it hides some details, but they're still way more explicit. And yeah, so one thing you need to know in Rust is that there are 2 types of errors that you need to differentiate. One, we call it recoverable errors, and one, we call it non-recoverable errors. Let me talk more about the unrecoverable errors first. So unrecoverable errors is like non-recoverable errors, where when things break, just like quit, don't care. don't care anymore. This one is like, for one example is this. For example, you have main, then I create a vector. Vector is, if you don't know about that, is like a list in other languages, except the vector is resizable. You can resize and increase the size. So what I'm doing here is I'm getting like 99, the item 99 here, the 100 item, because it's indexed from 0. So once I get 100 item here, and then you get panic. So boom, you get bomb. And then when I run it, there's a error here. So this is a panic message, but the old panic message, because you remember just now in the first in the bus corner it says the error, the panic message is updated. So this one is still old. Yeah. And then so it says index out of bounds. 9 is 3, but the index is 99. And so this is the panic, as in you don't really need to handle. It's not the kind of things we want to handle. And here I show when do we use non-recoverable errors and when do we use recoverable errors. But basically, you just need to know when to use non-recoverable errors. Non-recoverable errors, mainly we use for memory errors, like you can't allocate the memory. Usually there's OS level side. Next errors. Next errors usually is non-recoverable also. But if you know there will be an index issue, then what you likely to do, what you do is how to say, you use the safe methods instead, like get and check whether they have a value or not. But index is safe in Rust, as in you panic when it access out of bounds. In some language there is not memory safe, like C, it will be undefined behavior. What I mean by undefined behavior is like when you access memory out of bounds, then you get memory safety issues, then it can turn into vulnerability. Or you can get undefined behavior as in anything can happen. It's just up to computer imagination. And possible errors, like sometimes you just don't want to handle the errors. You just use unwrap or expect. But exception, I think exception usually in like kernel code you don't really write. Kernel code you don't really write like non-recoverable errors because like kernel wants to handle all the stuff. So kernel code usually everything will be recoverable errors. And prototype, and when is it useful to use non-recoverable errors? I mentioned those cases like you didn't even talk about it. Usually it will be non-recoverable errors. And when it's useful is, for example, you are writing prototyping code. Because Rust is not a very good language to prototype, but still, you want to prototype, you can use unwrap. Because just unwrap, it will say Rust will force you to handle the errors, to handle it. Because it's like that. I mean, the language is explicit. If you miss handling one error, it will tell you. So at the very least, you need to put like dot unwrap. And you know, okay, next time you know you come back, you can just search for the word unwrap, where you unwrap, then you can see whether I need to handle this or not. So you know next time when you come back, when what is the part that I missed, or there can be edge cases not handled. Edge cases as in like errors that is not handled. And there's prototyping code. So you can prototyping code like writing lead code or something. Just unwrap. Examples in when you are writing the examples as in documentation examples, because Rust has the doc test where you show example to other people how to use that chunk of code. And so this one examples you can use unwrap as well, because it's not that important having to like handle the errors. And test as well, because test usually when it fail, just fail. So you can just unwrap test. So these are the cases. There is the all these are like running panic, because this all the panic. Then okay, now recover errors, we are done with it. Now let's talk about recoverable errors. The recoverable errors in Rust consist of something called result. It is a sum type, like sum type is like an algebraic data type. What do I mean by that? It means that it's like enum. What's an enum? Which is like something like enum, but it can contain data. As in, this combines enums and generics as well. So you see, result can be either okay or error. it can have two. There's two variants in result. The first variant is okay, which means result you get okay, good. And then error means times down, error. E here means of type T, can be any type, and then E also any type. So it can have two different types. So this is how Rust handle errors. And let's say we have an example error here. For example, we want to open the file. So file open returns a result found IO error. IO error contains all errors. Like I mentioned, this is one of the less explicit errors in Rust because IO errors. Yeah, I think there are reasons they do it like that because usually Rust errors, right, it will be very explicit as in what kind of errors they will show everything they will list down. But IO errors they can't do that because this one they need to cover different operating system, like Windows have Windows kind of error and Unix have their own errors. So maybe that's why they wrap it under the IO error. So this one will return either the file structure, or the IO error. And we handle the errors, including the result. And here we will say we will match. Match is like Rust kind of pattern matching. It will match. I think Python also have this now already, which is similar to the one you see in Rust. Rust one you see you can take in the inner value here already. For example, okay, right here is the inner value of file. And then you take in the inner value and then you take this out to creating file. And here, how do you handle error is if you do a panic. Just now, like I mentioned, panic is a non-recoverable errors. You just panic. In this case, when we open the file, you see a panic. It doesn't exist. And let's say sometimes, right, you say, oh, errors, who cares? You didn't handle. You purposely uncomment the code. So Rust won't allow you that because you say the errors you didn't cover. As you see, the Rust errors is the match is exhaustive matching, as in it needs to match all the different kind of cases. Okay, error, like both cases need to handle them. That's why this is also useful not just in error handling. Like for example, you have a enum type, it can contain many different types, like 10 different types. And but one day you want to add one new variant to the enum type in your code base. In other languages, what I see is whenever I do this kind of enum types, right? When I add a new type, new variant, then I need to audit the whole code base to see whether it breaks other parts. But what I like in Rust is that you error every part that you forget to handle. Then I need to go through error each of the part and then I'll add it back. But in other languages, usually if I miss, right, it means that it will be a production bug. Then I'll need to come back, go to production, then this got some issues and come back and fix. If that's the case, so that's why I quite like the exhaustive pattern matching. And let's say you want to solve different kind of error, so you can match and match again. You can match the error. So let's say the error is not found error, or other errors you can make. Then if let's say it's not found, then you can create. So this is like how you handle errors. You can match with match. So file create also returns same thing, but it will create a file. And next shortcut, just like I mentioned, the shortcut is like, for example, unwrap where let's say you don't want to handle the error, you just unwrap. Then you take the value. It is similar to this. Come here, like it will take the inner value. It will return the inner value, or it will like panic. So there's unwrap. Or you can just expect where instead of unwrap, the difference is the expect to have an error message. So when it panic, right, it will show the error message out. So there's the difference. And if like let's say you're new to Rust, you don't know, you should always try to use the expect instead of unwrap. Use unwrap when like let's say you want to do it quick, but then later on when you come back to code base, you see, oh, maybe this one should throw this error. Yeah, and you'll be more useful. But one thing I don't quite like here in Rust is for example, open the file. You see the error not found, right? When you pending didn't tell you what file path it is opening. So there's one thing you need to be aware of when working with the file, opening file, closing file. Because he didn't tell you what file, so when you error, right, usually what people do, they'll put in the context what file it. Not this maybe expect also can work, for example hello text, but usually people will try to put in the context. And next, propagating errors. Here is let's say you want to write a function and then you got error, but then you don't want to handle error, you just want to throw the error to the outer function. So this one we call it propagating errors. What we do here is the same as the previous one. Here, the file is here, you take the file, and then you put it, take the file and then you put it back to the outer part. You extract it. The difference here is that now you want to return error to the outer function. So you return error here. You need to wrap it because you return the result with the error. And then here is the same username, and let's say if you didn't handle it, then username this will be error. And then here is the same as previous. This is the syntactic sugar that Rust provides. As in, you put a question mark and then you do this part for you. So question mark means that you propagate error one level up. And something with some conversion, but I won't talk about that so much now. Basically, it will go up one level errors. Okay, go up one level. Then here you can put this, and then the code will be much shorter, be easier to read. You mean the stack trace? Yeah, you show the original. Yeah, which is here. And then here it will show, or you can chain them up. For example, because here you see question mark, right? You can just chain them together. So basically, this one like this one. Up to here, am I being here? Is there any questions? Okay, next I'll talk about the custom error types. And one of the pattern is that a lot of the times in other languages or whatever, you'll see you will need to create your own error types. In Rust, you can create with any type you want basically. And the better case is you implement the error type. And you can use this error for that, but I won't talk so much about that now. You can implement the error trait. But usually people don't implement that themselves. Usually people just use this error and then define and then derive the error trait. I didn't show the deriving part here. And here I have a function consume that returns an error, consume error if it's more than or equal to 10. In this case. So it looks like this. You want to use a custom error. You can use any type, you can use struct or you can use enum or whatever. This is custom error type. And next is what if you want to, like, what if I write the code but then can contain multiple error? How do I deal with that? This is a common question. In Rust, usually people recommend doing this as you create your own error type that contains different kind of error type. You can wrap around enum because I mentioned enum can wrap can contain data and can have multiple variants. So the previous part is the same. We are not touching that. And this part we have a new thing here called process, where we run through the process and then it can process error. The difference here is that it can contain IO error, or pass error, or consume error. And let's say IO error here, like the difference here is that there's a function here called map error. Basically, map error this is running lambda a closure where it takes in the error and then wrap it around IO error. Something. Yeah. So it looks something like this. Something like this, in case you do. Yeah, because this is only one argument in the error, and then that's why I do a shortcut here. But in other case where is the error is like more than one error type, or you want to take an inner error type, then you need to do with the closure thing. But here is like quite straightforward already. You just back then propagate. Then this one will return the process error. Why you need to do this is because let's say you have error, but here you're returning process error, right? How does the code know you are returning process error? That's why here, because like you see just now, the result can contain okay or error. Error is only one type. It cannot return like multiple types. It cannot return on this or this or this. But if you want one type, what do we do? Use enough that can contain wrap all these kind of errors. That's why you can have different variants of errors. Yeah. So this is how you wrap different type of errors. Then you can clearly when you are the user of the library, you know, or it can contain these few errors and handle them separately. So alternatives, sometimes you don't need error. You need like an option type where we call it nullable data type. Rust, because Rust doesn't have null, so there's this type called option where it can contain some or none. Some means there's value, none means there's no value. And this one you can replace it with like nullable type in other languages. This error quick is mainly for library code. It will help you to generate the quick and the necessary stuff for the to handle the errors, to deal with the deriving the errors for the structures. Anyhow allow you to easily add context to errors and propagate them throughout the code base. That's the difference. But usually people think in a way, okay, this error is for library code, anyhow it's for application. It's easier to understand. But you can use both also. Yeah. So there's these two crates are done by the David Tony. Yeah. So he mentioned the Serde. Yeah, so Serde is a serialization library in Rust. And the guy wrote that as in the code will generate the serialization and deserialization as in converting from JSON back towards and back from JSON. I can show them. So it looks something like yeah, for example, this one is a cert. You can convert from JSON. So you generate a serialization, deserialization here, you write it. Then here you can convert towards from JSON. So this is how serialization, deserialization is done in Rust. It's not built into the standard library, but this is like pretty much like the de facto standard library people go with. The benefit here I see is that it provides like you don't you don't need to say you want to do this with what formats. It works with CSV, JSON, whatever format. And then one thing I quite like is that you can transform the type, like you can transform this X and Y, you can transform. For example, you say you want camel case, it will automatically change everything to camel case for you. So that's the difference. Okay, so this one is branding. Any ever handy? Oh, that one I didn't show because that one is like when you want to propagate out of the it is here.
I used to generate
Yeah, you can do that also. The one I show is like maybe yeah, it's like this where you have a box line error where you handle all different kind of errors with a box. Box is like a smart pointer in Rust where you box the like you keep that thing in chip memory. And then here line error is how to explain. Line error is like a crate So here is a dynamic dispatch where everything implements the error trait. You can return it. So in this case, because almost everything implements the error trait, then you can do this. You can box line error, but you can't put line error because you don't know the type at compile time. So box will help you to handle that this box line error part. Up to here, any question?
Anyhow, the application, but only in never different. So the promise is you just add context and always just but sometimes it gives error, just doesn't
Anyhow.
Anyhow, or like just like this blocks the dynamic error. Sometimes it doesn't work. Like the whole conversion thing was just I'm very new, so it just doesn't always work. Because you have to like the explicit mapping.
Is it because your own type doesn't implement the error trait?
I use any. I just like, go for any application. Okay, I'll go with anyhow. But it just gives error and I don't know what to do.
One thing quite nice about anyhow is that there is a context, right? And context to errors.
But it doesn't always work.
Doesn't always.
So sometimes it gives errors. I don't know. Like sometimes like when I'm mixing up with other errors, it just doesn't end up. But there's nothing against. I don't know.
Yeah, am I being clear? Is there any question? No? No question. YouTube. Okay. Let's proceed to the next talk. That'll be a bit deeper. Yeah. So I'll try to do at least one beginner talk every time, so people don't get too bored with the deeper talks. And a lot of time people heard Rust is slow. Why is it like? Because Rust needs to compile a lot of things. Just now you see that just the error types check so many things. And then there's debugging, the traits and stuff. Rust does a lot of check during compile time. That's why it keeps the language safe. And yeah, people say Rust is slow. Why? Because I see people compiling 500 plus crates and then they say Rust is slow with hello web. And then because they compile a lot of library code, because Rust you can put in library code very easily. So sometimes people tend to put in a lot of code, especially when you are building web stuff. Or maybe not just website, you build front end also, Rust puts in a lot of stuff. So yeah, a lot of time people say slow. Then what you do just one thing you can do first step is like mentioned in the art of war, the 知彼知己百战百胜 means that you know yourself, or you know the others, and then you know yourself. Then in 100 battles you win all the battles. Means you need to know both sides. Then come from the book out of the war. So what you need to do here? First thing you need to, of course, you need to know where is the slowest part. That's why usually benchmarking happens. And here you can see cargo comes with something called timings. When you can show the cargo build timings, it will show you the graph of each crate, how long does it take to build, and it will also show you like which part is building which part. The blue and purple part is building two different parts. Some of it is like running script also. Then you can see although it's built in parallel, sometimes you cannot build in parallel. You see it will build multiple. And here you know which of the crate is slowest, and then you might want to like tweak that, fine tune that. Basically like how you do benchmark, find the part that takes the largest hit benchmark, like speed up the part. One thing to note is maybe you want to always try cargo check instead of cargo build. You just run cargo. I don't run type check, just type C. Okay. C and D. So cargo C, cargo B, and then check. You run the check. You run everything lean type checking and borrow checking. Do all the things that keep Rust safe. There's like very rare. Sometimes cargo check break. I don't know why, but there's some bug somewhere. But very rare. Last time and then when usually you heard the saying like they say when any compulsive works right in Rust, as in beside logic errors so check also works. You run check and then you will show you all the errors and then you just fix the errors. So what we call it compiler driven development or something where you build until it compiles then it runs the code. Or alternatively, you can use the Rust analyzer XP, the language server Rust analyzer. There used to be something called Rust XP or something. But this one is a newer one. Both have different architecture. Basically, this one is more advanced where you incrementally compile the code because the design server is different now. And remove unused dependency. This should be straightforward, but there's a tool for you to help you with that. For you, that's then it will automatically find the dependencies that you don't use, and then tell you. Then you can see what you can do with it. But you need to use like the compiler. It will tell you the dependencies that you don't use, and once you remove them, yeah.
But if you don't actually use them,
Yeah. I don't like what is. Usually I don't keep extra dependencies.
Why would you keep extra this anyway? Yeah.
But once you know, some people might forget to remove dependencies. So this one you can just run it to check. Double check. Not just the errors, not just the dependencies. There's also a tool to help you to check for the features. You know the crates, right? You run the libraries. When you build them, there's a features. Sometimes you can search for the unused feature also can. Then you can remove that. But I didn't show that here because removing features doesn't always speed up the compile. Yeah, sometimes it will increase dependency risk also. No, security risk. So that's why I didn't show that here. Next is to find duplicate dependencies. As for how cargo works, cargo is the Rust, like the build tool, where it builds all the tool. One thing you need to note is that, let's say, A depends on B version 1, C depends on B version 0.1. So you see here, we have two B versions. In Rust, you combine both. In certain languages, only one version of the code is allowed to be running at one time, right? But in Rust, right, it will use both. So that's why sometimes you see both the same. How come the same library was just compiling and then now it compile again? So this is the case. What you need to do is you can cargo tree duplicates. You can find all these kind of duplicates in the code, and then you can contribute it back to the community as you bump or you go to C and then submit a pull request. Tell them B is updated, and then you update it. Then you have one less. That's duplicates. I find this quite useful. And replace heavy dependencies. This example is these are very popular quicks. Usually you don't need to worry about it. But in case you want to speed it up, you can use miniset urec pickle apps. That is like I mentioned, deceleration library. Request is like a Python request. A simpler HTTP request framework. Library. And then is a command line argument passing. So it passes the command line argument for you. And then you have a cargo tree and cargo boat. You can check. Well, cargo tree will list down all the dependencies. Cargo boat will check like which dependency is heavy. If you are more extreme, you can try to prevent all those dependencies on the procedural macro crate. For example, cert is procedural macro crate. But the issue with procedural macro crate, right? Why it is slow is because the libraries that's needed for procedural macro crate, like the scene, those are slow. Prop macro tool. Yeah, but this going extreme up. Okay, next is use workspaces. In Rust, there's something called workspace where you can split the code base into different libraries. Like you have your internal library, and then this one you split them one big crate into smaller crates. So you can look into this because you can compile them separately. Yeah. Next is next test. it's like next generation testing, but for Cargo. And then this one they say is up to 3 times as fast as Cargo test, but I'm not sure about this one. There are some caveats, but I think I quite like their idea. But then too bad it comes with Cargo test. I think if they want to change this thing right to next test, it will break the heat. Yeah, but it's quite interesting. Next trick is you can, let's say you are doing the integration test. You want to combine all the different integration tests into one binary. What do I mean by that? Like usually when you do the compilation, you have for example you have for example you have, let's say, you see you have this, but then when you compile the integration test, right, you see that there are many, each you have, like, let's say you are in the integration test folder, you have 10 files as file to test the code. So it will compile them separately, which is slow. The faster way is you put all of them to one single, to separate file, and then you link them to one single main test file. And the test file contains all the different other files to test. Then you compile into one single binary, and then you run all the different tests. So this is one way to speed up the integration test. One trick. Okay, next is use faster linker. There's something in Linux called mode, which is the linker is faster. Linker, in case you don't know what is the linker, is like when you compile the code, right, you need to link them to a single binary, and then there's the part where is doing, where you link the binary. So mode is like a faster linker in for Linux. For Mac, there's something called LD, but now there's a LD is replacing that. Like, yeah, yeah. But for Windows, I don't think there's something like that. So all in all, the main thing is you want to make the cluster just control your dependencies. Make sure you don't put in unnecessary dependencies. Yeah, yes, all that. So there's this. Is it too advanced? Hard to understand. Is that no? Yes. Question?
Different versions that are so many that like Java to the wrong version, wrong
Certain cases, yes. Let's say some libraries doesn't work with certain versions libraries. Like for example, last time back then when there was like Tokyo 0.3 back then, right? It doesn't work with that Tokyo library. But other than that, usually it works out. But those cases are very, very rare. Yeah, very rare. But let's say you want to use Tokyo, since like those base library like Tokyo is already stable now, then everything is like stable. You don't really face that. Yeah, but back then because Tokyo you need to communicate with the same kind of structures everywhere, right? For the basic construct for asynchronous stuff.
In really like, let's say if you want to realize the realize something like Rust, you need to use S. So I was wondering, for that case, I mean, it was with that we develop code in Rust that we can, in let's say something like that serialization that we can use that internal library that Rust provide. In terms like, can we like develop Rust without using like some other,
Libraries.
yeah, I mean some other libraries that we can use, like let's say in Go, right? So we have like for the acceleration we have unmarshaled and marshaled. So I was wondering like can we like build them without using those kind of
The Saturday.
yeah
You if you want to build them manually, then it will be a lot of work. So
yeah.
because the
Yeah,
Rust
this yeah, that's one good thing about Go is like Go have everything built in, standard libraries, everything built in. Unfortunately, Rust we don't have that. Like for serialization and deserialization, for example, you need external libraries like Serde. Yeah.
for us, a few of the libraries that people think should be in standard library, but it is built by a community. I quite like the approach as in some of the libraries is maintained by the Rust core team. Few of these libraries you see quite often is, for example, random, the crate random. It is built separately. But one thing quite interesting is that because it's built separately, it can evolve on its own. Now the random can includes a lot of different kind of weird things like the binomial distribution kind of thing also, which you don't see in other random libraries. So it handles those cases. And then Saturday also, since it's built separately, it's like on there's a few approach back then. And then now everyone go with Saturday. It's like quite stable. Another one like Tokyo. Although they are competing, although Tokyo is like the async library in Rust, although they are competing libraries like async STD, but they are dying out. Maybe because like there's no paper to go and work on that. Yeah, so it's like async runtime in Rust. The only downside in Tokyo as in like it have their own way of certain things they want to do certain way, which some people may not agree with. That's why people come out with async STD. But the certain things as in, for example, in Tokyo, a lot of stuff needs to be sent and sync because Tokyo works with multiple threads. Tokyo, Tokyo is an async library, async they apply async runtime, and then it works with multiple threads and multiple and then it have the work stealing. Okay, so it means that the task running in one thread can be sent to another thread. That's why a lot of all the stuff in Tokyo expect all the stuff all the tasks we execute to be send and sync. Send and sync is the thing in Rust to say that the function everything in the function you can send to another thread, can be shared between threads. Like something like this high level you can mean is thread safe. Both if you have these two, if everything have these two traits, it means that it's safe. Compared to this is a thing different as in C you see this in the documentation. So you read the man pages, then they'll say, okay, this function is thread safe, or this function is not thread safe. But if you forget the documentation, then different things will happen. But Rust is constructed as trait, as in send and sync two different meaning.
In Python we have request we have request ID. So if we don't use the B, it was kind of like pain to like simple request to recipe request. We can use standard, but we have to do like a lot of work.
In request library.
Yeah. I mean no, without using request.
Yeah, I think a lot of work. But the like for example the third party libraries is quite easy. For example, let me show a demo. For example, let's say you want to create a project, you want to for example, let's say I will do hello world with and then so I have Rust code hello here, and then let's say I want to include a library. Including a library is quite easy in Rust, as in I want to add cert. For example, I want to do the JSON, I'll add cert derive, and then cert JSON. Okay, so these the two library that we need to do the serialization and deserialization in JSON. Yeah, these are something I can PM install. So this one So this command is to show. Usually what I do is I open the documentation locally, then I'll compile and run documentation locally. Then I'll see like how to use this. Yeah, see suggested how to use. Then I don't really want to think I just copy paste this. Hello. Yeah, but basically, I don't remember the code, but basically you add the cert library through this, and then when you write the code, it's something like something like this basically. Copy paste code. Then when I run it, then you run the code on. I just found the one. So this is the serialized and deserialized. And you can see you just import this and then do this to do this two thing and then convert to the convert. Quite should be quite straightforward. So adding library is not by the compile time.
I mean, I don't like to add more dependency. Right. I mean, like, say, how, yeah, that's kind of point, right? I mean, you have to.
Anyone else have question? That one you need to you add you add this you add to your cargo config token, then you add your target. So you add these few lines and then you see go move, then you run with the move. Mainly the difference with mode is that it can utilize multiple threads to doing the linking, but it's slightly faster. And any kind of function doesn't really have to be like that. Any question?
More about
Next topic. We can't give talk. Okay, parallelization. Maybe I can share a bit. As in, there are a couple things. So usually there are two things. If you mean parallelization, do you mean the rate, like the CPU kind of, not IO bound, right? Not IO bound issue, right?
I see.
Yeah, actual parallelization. Usually in Rust, you do the rayon where you add. In Rust, like, let's say you use the iterator. Maybe I show a quick example and talk about that in talk. So Rust usually we use iterator to iterate over code. For example, you have this text. It's like basic iterators where you see in other languages, you go through the code one by one. And then you can do map where you can iterator map. Okay, for example, you want to map each function. Like here, 1, 2, 3. 1, 2, 3 become you multiply by 2 become 2, 4, 2, 4, 6, right? And let's say if you use this infrastructure provided by Rust, the iterator, let's say after that you want to switch your code. Let's say your code is slow. You want to make your code faster. How do you do that? There's a tool called Rayon in Rust where you can just you can add like PAR underscore, which means parallelize the operation. It will parallelize the map for you. And then just add that and then your code magically become faster. Yeah. That one, it will check how many CPU you have. And then it will run based on that. Usually. I think you only check once. You will do some lazy initialization code. And you this one I'm not sure. I didn't check your code base, but I believe they will only check it once. Yeah, usually that's how people do it. But if let's say you want to do it manually, you create a thread and then you submit the task and then do it one by one. Then there's the other way. But usually I use this method because it's like way easier. You just use the iterator and then add 4 characters, then you parallelize. Any other question? No? Jeffrey? Jeffrey, do you have a question?
No, I don't have.
Okay, so yeah, thanks everyone for joining the Rust meetup today. Hopefully you'll learn something new. And again, I'll mention again for the next today will be the last offline meetup for the year because although we do it bi-monthly, next time we will do an online workshop instead, which will be any Chinese focus. The communication will be in Chinese because it's requested by a group. So we will do it in collaboration with the group. You can join. We'll try to use both languages, and then I think people from Singapore will also join since some of the people in the group is also. Then we join, and then we'll do a workshop. Since last time when we do the workshop, it's mainly more kind of lecture kind of workshop, but this time we'll try to make it like exercise focused. So it will be like self-learning kind of job, but we will guide, we have mentors to guide.
Thank you.